Hey everybody, Sebastian here, back again. This time doing a challenge question video. So in this one, I'm going to be doing 6 challenge questions that are questions that, I think students have had that they feel are very difficult from the SAT. And what I've done is create questions that will help you tackle those questions. And I've done for each of the 6 hard questions, there's one slightly easier question to help introduce you to the topic. And then we get into one I created that is supposed to really help you master the topic and think about the question in a creative and, helpful way. So let's try this out. So the first question we have is an isosceles right triangle has a perimeter 72 plus 36 root 2. What is the length of the triangle's hypotenuse? Okay. So in this question, right, for anyone who wants to remember right, isosceles right triangle means the two legs are the same. And that means they're 45, 45. And it's x, x, x root 2. So in this case, we're going to have the perimeter would be 2x plus x root 2. So it's going to be 2x plus x root 2 equals 72 plus 36 root 2. And then we can factor out an x. And we're going to get x parentheses 2 plus root 2 equals 72 plus 36 root 2. And then we're going to divide by 2 plus root 2. And we're going to get x equals 72 plus 36 root 2 over 2 plus root 2, right? And then from there, what you notice, right, is that 72 is double 36. 36 has a root 2 attached. So 72 equals root 36, or 36 times root 2. So almost from this step, you could have said x equals 36. And if you divide this out, right, you're going to get x equals 36. And that is the leg. And then to find the hypotenuse, you would just do 36 times root 2. You could put that in the calculator and solve, right? We're not going to do that. We're just going to leave it as 36 root 2. But the thing about this question is that from this step, it feels very natural to say x equals 36, okay? And if you divided here, you would also get the same thing, right? If you plugged in, because you see the root 2 there, 72 doesn't have a root 2, 2 doesn't have a root 2, but they're both just root 2 times the 36 root 2, okay? So then you could also have thought about it as 2x equals 72, and you could get x equals 36, okay? So now we're going to do another question that's basically identical, but people struggle with it more because the numbers just feel less intuitive, and you'll see why in a second. Okay, so for this one, right, it's very similar, except an isosceles right triangle has a perimeter of 72 plus 72 root 2, right? So this time it doesn't seem as clear which one you're talking about as the hypotenuse and which one is the legs combined. You'll see why in a second. What is the length of the triangle's hypotenuse? So again, we draw it out. All right, I'm going to make it kind of small to have room for to do the other math. And it's going to be x root 2 again. And then I'm going to get as the perimeter 2x plus x root 2 equals 72 plus 72 root 2. Majority want to think that this is the hypotenuse, right? And I think some people would put that, but that's not correct. What you want to do is factor out the x again. 2 plus root 2 equals 72 plus 72 root 2. And you're going to get x equals 72 plus 72 root 2 over 2 plus root 2. Now I'm going to multiply both top and bottom. You could do this in the calculator, but I'm just going to show you the conjugate method, right? So minus root 2 on the bottom, top, 2 minus root 2 on the bottom. So on the bottom, right, the 2 times 2 gets you 4. So this becomes 4. This becomes plus 2. So you have 4, 2 root 2, negative 2 root 2. And then negative root 2 times positive root 2 is going to be negative 2. So these cancel, and these become 2. So the bottom is going to become 2. Okay. So I just erased a bit. So we have 2 on the bottom. And now let's do the top. 72 times 2 is going to be 144, right? That's outside, first times first. Outside times outside is going to be 72 root 2, right? Because it's going to be 72 times that minus inside times inside is going to be plus 144 root 2. And then last times last is going to be 72 root 2 minus times negative root 2. So it's going to be minus 144. So these cancel. These partly cancel, and you're going to get on top 72 root 2, which you divide with the 2, and you're going to get 36 root 2. That equals x. And we're looking for the hypotenuse, so we're going to multiply x by root 2. So x root 2 is going to be 36 root 2 times root 2. And that equals 36 times 2, which equals 72. So the last one, right, the math feels a little bit more counterintuitive than the first question. And now we're going to do this question. So that last one, right, the math felt kind of counterintuitive on the second question, while the first question felt a bit more natural, I think, the numbers. So again, we're going to practice here on this question, and then we'll ramp it up a bit on the next question. So it's very simple, right? If 2 to the 30th equals 8 to the 2x, what is x? So you could find what 2 to the 30th is, and then, take it to the log power of 8. But that's not going to help us here because 2 to the 30th might be so big it doesn't even come up on the calculator correctly. And I want to do it the way that you'll do it with other questions to see how it works, but this one will illustrate it. So 8 equals 2 cubed, right? We want to have the same bases or the same exponents. Here we can have the same bases. So 2 to the 30th equals, instead of 8, we're going to do 2 cubed to the 2x. And a power to a power you multiply, so this equals 2 to the 6x equals 2 to the 30th. And now things are a lot simpler, right? The 2's can cancel and you get 6x equals 30x equals 5, right? Nice and easy, not too bad of a question. Now we'll do one that feels harder, but actually is very similar. Okay, so in this one, right, there's no numbers. There's only numbers in the exponents, but the bases we don't know. But we can connect them, right? Because we know this base is this to the power and this to the power. It's just the same way we know, right, 8 equals 2 cubed. We now know n equals n to the 5/4 equals m to the negative 3/7. So let's work it out, right? So, and we have n here. So let's find n and set it equal. So to get n, we're going to do to the 4/5 power for both sides. So we're going to do n to the 5/4 to the 4/5 equals m to the negative 3/7, also to the 4/5. These are going to become 1, so we get n equals m to the negative 12/35, right? Okay, so now plug this in for n in this equation. So, because then we'll have the same base, m to the 3k minus 2 equals m to the negative 12/35. These go away, so 3k minus 2 equals negative 12/35. The math's not beautiful, but it's not hard either. So we're going to get 3k equals, we're going to add 2 which is like adding 70 over 35, right? So 70 minus 12 is going to give us 58 over 35, and we're going to divide by 3, which is like multiplying the bottom by 3. So k equals 58 over 105. Okay, so again, the math itself, pretty simple, right? Like this equation is just an algebraic equation. This part is just knowing how to get exponents simplified, right? And using fractions to multiply to 1. And it's just using the same rules as you've learned since like 6th or 7th grade, right? What you do to one equation, you have to do to the other equation. So these can be very challenging. I saw people talk about how questions like this are very challenging for them in the SAT. But if you think about it the way you would do the 8 and 2 question, if you do it this way here, it's straightforward, right? What the SAT does is it takes something that's concrete and feels easy when it's concrete, and they'll make it abstract on the really hard ones. So if you remember to do the abstract as if it were concrete, because it is, then you can work it out. All right, so let's try another set. I'll do another easy one and then a hard one. Okay, so these actually, this level and the next one are about the same, but I want to do 2 of them just to sort of strike the project home, right? So this is converting units, which if you've done chemistry or biology, you've probably done a lot of. So we have 36 feet over seconds squared to yards per minute. So to convert feet to yards, you want to have feet on the bottom, so it's going to be 3 feet, because the feet cancel, right, the units, and there's 1 yard per 3 feet. And then to convert seconds to minutes, you're going to do 60 seconds on top over 1 minute. And it's squared, so you want to do that twice, times 60 seconds over 1 minute. And then what's going to happen is the 3 and the 36 cancel a bit, so we got 12. 60 times 60 times 12 is going to be 60 times 60 is 3,600 times 12 is going to give us 43,200. And that would be yards per minute squared. Okay, so it's gone up a lot because even though yards are bigger than feet, so that would make it go down, right? We're dividing by 3 there. Minutes are much bigger, and we're doing it twice. So we'll try another one with kilometers, so there's exponent involved there, but still not too bad. Okay, so here we have convert 28 kilometers per second squared to meters per hours. So it's still not too bad. We'll see how we do this one, right? 28 km, right, over squared. We set up the same type of like system. So to go from kilometers to meters is going to be 1,000 meters on top. You could think about it as 10 to the third if you want, m, over 1 kilometer. And then to go from seconds to hours, it's going to be 3,600, right? Because it's 60 times 60, there's 3,600 seconds in an hour. So we're going to multiply it by 3,600 seconds over hours times 3,600 seconds over hours, okay? And this is going to get us 28 times 10 to the third times 3.6 squared. All right, I'm just combining in an exponential way, and then we'll get the math. Times 10 to the third times 10 to the third. So that's going to give us 28 times 3.6 squared times 10 to the ninth. You don't need to do this, right? I'm just doing it for fun, but you can plug it in the calculator like I'm going to do right now. And you're going to get 3.6288 times 10 to the 11th. Okay, so big number. They probably wouldn't have such a big number there, or if they did, they would just say, they would simplify it in some way. But again, same process, right? I think the big numbers, the kind of confusing numbers can throw people off when they're not so clean. But again, not too bad a question. It's something you do, unit conversion, right? You'll do that in chemistry or physics. This specifically would be physics, right? Because it's like acceleration, but they're not in the standard units, right? Because it's usually meters per second squared, but not too bad. So let's go on to the next one. Okay, so this is a fun one. A lot of times people have trouble with three-dimensional geometry, and cylinders can be a tricky one. So we'll do 2 cylinder questions, and this is a little bit simpler than the next one. So if you get this one down, be ready for the next one. Right cylinder A is similar to cylinder B, so that means they're proportional, right? Cylinder A has a radius of 4 and a volume of 48 pi. Cylinder B is 9 times the surface area of cylinder A. What is the height of cylinder B? So this is important. A radius of 4 and a volume of 48 pi. So if it's 9 times the surface area, I want to show you something very important that will make your life a lot easier on the SAT and in math in general. So let's say you have 2 squares, right? And the squares each have, well, they're both squares, so they're proportional. And let's say this one is 2 by 2. And this one is 4 by 4, right? Here, the dimension is half of this. This is double, right? So the area here is going to be 4. And the area here, 4 times 4 is 16. So to go from here to here, you double. And you go from here to here, you go 4. What's the relationship between 4 to 2? 4 equals 2 squared. So area is always the square in terms of proportions, right? For similar things, the square of the proportions in the lengths. Volume is the cube because volume is 3 dimensions. So we did the volume, right, and went like this, and we added another 2. The volume here would be 8, and we do it here, and add another dimension that's also 4. Now it would be 64. We would have 64 divided by 8, which is 8, which equals 2 cubed, right? So the proportion of area and the proportion of volume stem from the proportion in the lengths. Okay, so why am I telling you this? Because I'll make this question easier and I'll make the next question easier. Volume here is 48 pi. What's the volume of a cylinder? V equals pi r squared h, right? So then in this case, we are going to find 4 squared is 16. So we have 16 pi h equals 48 pi. H equals 3. Okay, and then we don't need to find the surface area of the other one or the surface area of this one. We just know the relationship is 9 times. If the surface area is 9 times, we do square root of surface area, 9 square rooted. To find 3, that means the length of cylinder B is 3 times. So LB equals 3LA. And you could say SAB equaled 9 SAA. And if you wanted to, you could say VB equals 3 times 9, 27 VA. But we don't need to worry about that, right? We just need to worry about the fact that the length is 3 times. So the height is 3, and this is 3 times it. The height of B, HB, will be 3 times 3, right? From this one and this one gets you 9, okay? So you don't have to find the volume of cylinder B, you don't have to find the surface area, or even really the radius. You just need to find the relationship. So now we'll try another one of these, and you'll see how this can apply to that. Okay, so in this one, I'm going to keep this box just to remind us of the relationship between length and surface area and volume. So here, right cylinder A is similar to cylinder B. Cylinder A has a radius of 6 and a volume of 108 pi. Cylinder B is 8 times the volume of cylinder A. N is the surface area of cylinder B. M is the surface area of cylinder A. What is NM? Okay, so surface area, right? We're going to have to use the surface area formula here because we have volume, but we want to find the surface areas. So let's find surface area of cylinder A. Well, let's find h first. So VA equals 6 squared pi times h. That's 108 pi. 36 pi h divided by 36 pi h equals 3 again. Okay, so now we have 3. So that means surface area of A equals, the surface area is the area of the two circles on the outside of the cylinder, right? So it's like, you know, you have a cylinder. So this is a circle. Sorry, these are terrible cylinders. But it'll be 2 pi r squared for the two circles on top and bottom, plus the thing going around, which is the height, times circumference. So that'll be 2 pi r h. Okay, so to find n, right, n will equal, no wait, sorry, to find m will equal 2 pi 6 squared plus 2 pi 6 times 3. So it's going to be m equals 36, 72 pi plus 36 pi, and you could say units squared, but it's okay, you don't have to worry about it. So actually, interestingly enough, it's the same as the volume, which might feel like a red flag, but it's okay, it's correct. And then to find the surface area of cylinder B, instead of multiplying by everything, you take the surface area here and you multiply by, first find the length difference. So 8 cube rooted equals 2 equals length ratio. So surface area ratio equals 2 squared. That equals 4. So it's going to be 4 times as big. So n equals 108 pi times 4, which equals 432 pi. So then n minus m, I'm going to write that up here, n minus m equals 432 pi minus 108 pi equals 324 pi. Okay, so this, right, I don't know if you would actually get a question like this on the test where it's n minus m for a free response, but they could do n minus m for multiple choice, because then it's not so easy to like plug in and see what happens, right? When they do the addition or subtraction on multiple choice, they will often do that so that you can't use the answer choices as easily as you normally could. But you don't need to, because you could do it free response anyway now that you see this, right? So it is 324 pi. You could plug that into the calculator to get a decimal, but this is how it works. So if you have questions on this one, let me know. It's definitely a tricky one. I think the cylinder surface area equation is very not used, or very uncommon. So you want to freshen up on that. I don't even know how often these come up, but it's good to practice. And the important thing, the thing I really want you to stress is this ratio, right? I want you to understand how this works, how you go from the ratio of lengths to ratio of surface areas to ratio of volumes. All right, so let's try a couple more. Function passes through points -2, 0, 12, 0, and -9/2, 0. Which of the following is a factor of the function? So when you get these right, the factors are just the opposite signs. So you're going to have x plus 2, x minus 12, and x plus 9 over 2. Okay? So which of these is it, right? I made my minus, okay? So we have x plus minus 12, we have x plus 12. This is x plus 2, we don't have that as an option, we have these other things, right? X plus 2 over 9, we have x plus 9 over 2. So this x plus 9 over 2, right, can change. It can be written a different way, right? Equals 0. you could multiply everything by 2 to get the 2 out of the way, and you're going to get 2x plus 9 equals 0. And now it still gets you the same value. And if you look, you have D as an answer here, right? So this is one of the easier questions, I think, but still worth going over. And how did I choose all these questions? I wanted to do some geometry, some function stuff, some exponent stuff, just as a mix. I'm going to be doing this monthly, right? So that people can check in once a month and get 6 questions that are challenging, built on 6 other questions, right? It's kind of like a big meal, right? My other short videos are like snacks, and this is a big meal when you're hungry for math. All right, so let's try the next one. Again, we're making it abstract here, right? A function f passes through the points negative m over 0, n comma 1, and km 0. Which of the following is a factor of the function? I want you to notice they're tricky here with this n comma 1. This is not a factor. A factor has to have a 0, right? This is a remainder of 1. So this one's not going to work. So we're not going to worry about this m plus 1. Let's look at our answer choices. mx minus k, x minus m, kx plus m. So if it had been x minus m, this would be x plus m. This one can't even give it to us. And then this one would be x minus k over m. Okay, so let's work on that one. X minus k over m equals 0. We multiply everything by m. And we're going to get mx minus k equals 0, which is, dun, 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 a, right? So again, not too bad. I hope you can see how you can abstract like this, and I want you to think about this and think about how to think about these as though they were easy questions and how they're built on simple steps, right? There's nothing so crazy here. You're not doing calculus, you're not doing linear algebra, you're doing algebra. And if you remember that, you'll be fine. Okay, so I hope this video helped. I hope it was fun. I had fun making it. I had fun making these questions and trying to come up with ways to challenge you. And I hope you've had fun watching it. So I'm going to keep making my daily videos. What I'm doing now is something like this, where I do short videos with 2 questions, an easy version and a hard version. Sometimes the hard is not hard. On this video, I really wanted to make them challenging, so I think they're all quite hard. And if you can get all of these, you're probably scoring really highly on the SAT. And then I hope you're all doing well, that it's sunny where you are, and if it's raining, I hope it is cleaning your windows and watering your plants and making a beautiful little drizzle on your rooftops. Talk to you soon. Bye.